Okay, today we're going to talk about the last new concept of Chapter 1, and these two concepts are called linear pairs and vertical angles. Now, linear pairs and vertical angles both happen when lines intersect something. Linear pairs are simply two angles that are adjacent and supplementary, to use the words from yesterday. So angles 1 and angle 2 here, as we can see, are a linear pair. The name is descriptive, linear pair. It is a pair of angles that makes up a line. A pair, not a triplet or 4 angles or 6 angles. A pair of angles that when you put them together, you get a line. And again, they have to be adjacent, means same vertex, common side, and they have to be supplementary. Vertical angles happen when two lines intersect, and vertical indicates the two angles that are across from each other. In this case, angle 3 and 6 and angle 4 and 5 are both examples of vertical pairs. There are no such things as horizontal angles, only vertical angles. It has nothing to do with their orientation being up, down, vertical. It's not that type of vertical description. It's a different meaning for the same word. So vertical angles are angles that lie across from each other when two lines intersect. Or definition, the two pairs, they form two pairs of opposite rays. To me, that's a little more of a confusing definition. Just look at the picture, learn the picture. Now, not only do I have linear pair or vertical angles in this picture with 3, 4, 5, and 6, I also have several sets of linear pairs. For example, 3 and 4 are a linear pair. 4 and 6. 6 and 5, and 3 and 5 are all linear pairs. So when two lines intersect, I get a whole mess of linear pairs and vertical angles. Special things to deal with. So these are just some of the angle pairs we're going to be dealing with quite a bit. We'll deal with other angle pairs a lot more in Chapter 3. So identify linear pairs and vertical angles in the picture. Now, this picture would be super simple if I didn't have this ray right here. If I didn't have that ray, we'd have a pretty easy time working with this picture. But because that ray is there, it does complicate things a little bit. So let's start by naming the linear pairs. So two angles that when I put them together, I get a straight line. They have to be adjacent, so same vertex. So angle 1 would be a linear pair with angle 4. Oops, I do want a second arc there because it's there. So angle 1 and angle 4 are a linear pair. Is there another set of linear pairs here? Well, sure, 4 and 5 would seem to go together as a linear pair. Okay. How about 5 and 3? No, that doesn't make a straight line. We're going to put 5, 3, and 2 all together, all of them. That makes a straight line. Yes, but what? The problem is linear pair means pair, two angles. I can't use 3. You're right. If I added 2 plus measure of angle 2 plus the measure of angle 3 plus the measure of angle 5, I would indeed get a 180. But that's not a pair of angles, so not a linear pair. Angle 1 and angle 2, no, not right. 2 and 3, not right. Okay, so I think I found all my linear pairs. Vertical angles. Vertical angles have to happen when two lines intersect, which means that I really can't work a lot with this ray here. Any angles using that ray right there aren't going to be vertical because it's not a line, it's just a ray. I need two lines intersecting. So what would be vertical pair? Well, angle 1 and angle 5 here are a vertical pair. Angle 3 is not vertical with anything because there's not an ray over here. 2 and 4 are not. They're kind of, but I need 2 and 3 together to be vertical with angle 4, but I can't do that. It's just vertical angles, just one angle. So my only vertical pair there is angle 1 and angle 5. That is my only vertical pair. Two angles form a linear pair. The measure of one angle is 5 times the measure of the other angle. Find the measure of each angle. Again, no picture given, and just a verbal description. How are we going to deal with that? Start by making a model. Model being a picture. It's a linear pair. I love linear pairs. They're super easy to draw. It says one angle is 5 times the measure of the other angle. So if this angle is x, this is the big one, it's 5x. And what is the relationship between those two angles? Do they add up to 90? Are they equal to each other? Do they add up to 180? Do they add up to 135? Are they brother and sister? I don't know. What's the relationship? You're going to hear me say that all the time this year. What's the relationship? Life is about relationships. Geometry is about relationships. What's the relationship? Mathematically, how are they related to each other? In this case, since they're a linear pair, it means they're supplementary. They add up to 180. And from there, it's pretty simple to solve. X is 30. So that means if this angle is 30 degrees, that this angle has to be 150 degrees. And is that my answer to my question? Find the measure of each angle? Sure. We don't have specific names for the angles, so I can just indicate the angles are 30 degrees and 150 degrees. Are there any numbered pairs here that form linear pairs? Any numbered angles here? Any pair of angles that form a linear pair? In this picture we're looking at now. Do you see any numbers that give you a linear pair? Well, 6 doesn't, and 5 aren't linear. 6 and 1 aren't linear. 5 and 4 aren't. 4 and 3. In fact, there are no linear pairs here. None whatsoever. There are groups of 3 that add up to 180, but there are no linear pairs. How about vertical angles? Vertical angles? Oh, yeah. Angle 2. Same lines make up angle 5. Same with angle 1 and angle 4, and angle 6 and angle 3. Those are all vertical pairs because they're formed by the same two lines. Let's take a look at this next one. The measure of an angle is twice the measure of its complement. Oh, this is going back a little bit. Find the measure of each angle. So the key word here that tells us the relationship is complement. Complement means they add up to 90. So if one angle is twice the measure of its complement, so I've got two angles, they're going to add up to 90. They aren't necessarily adjacent. And one angle is twice as much as the other one. There's a nice little model. They add up to 90, so there's my relationship. So x is 30. The measure of the angles, therefore, are 30 degrees and 60 degrees. Two angles form a linear pair. The measure of one angle is 1 1/2 times the measure of the other angles. Find the measure of each angle. Again, making a model, key relationship here is linear pair. So we're going to model that. One angle is 1 1/2 times the other. So if this is x, this is 1 1/2 or 3/2 x. A little trickier because of the fraction, but we can work with it. So x plus 3/2 x is 180. There's my relationship. Now, couple choices. I can just work with a fraction, or I could multiply through everything by 2 to eliminate the fractions. It's up to you. Now, with just a half, I usually work with it because this is 2/2 x, 1x plus 1 1/2 x. So I get 5/2 x is 180. So x is 180 times 2/5, because divide by 5/2 is the same as times 2/5. So that's 36 times 2x equals 72, I believe. Let me just double check that. Doing it in my head. So 180 times 2. Sorry. Gotta get the right symbols in the calculator. Times 2/5. Yep, 72. So the other angle would be that times 1.5, or 108. And sure enough, that adds up to 180. If you want to do the eliminate the fraction route, what you do is you multiply everything by 2. So alternately, you'd say 2x plus 3x equals 360. So 5x equals 360. And we still get x is 72. So if I took this original blue equation here and just multiplied the entire equation by 2, the 2 gets distributed to the x, the 2 and the 3 halves, the 2 cancels, the 2 in the denominator, and the 2 gets multiplied on the 180. That's where the 2x plus 3x equals 360 comes in. So you may eliminate the fractions, you may work with the fractions, it's kind of up to you. All right, final concept of this chapter. Interpreting a diagram. One of the things we really need to be careful of, and we've talked about this already, is jumping to conclusions based on a diagram. When I look at the picture up top here, it sure looks like I've got a right angle right about here, and maybe, just maybe, this ray BE here is actually bisecting angle DBC, making those two angles congruent. Maybe, I don't know. But I can't tell for sure based upon just this picture. Whoops. That was fun. Hope that didn't make you dizzy. Based on just this picture. I can't tell for sure what's going on there. What can I tell? Well, I can tell that A, B, and C are all in the same line. I can tell all those points are in the same plane. I can tell B is a point of intersection. I can tell that I have some adjacent angles here. But I can't conclude anything about their measures other than the straight line. However, when we look at the picture again down here on the bottom of the page, now we got all sorts of markings in here which give us all sorts of information that we didn't have before. So now I can assume things based upon the drawing. For example, we see the little red tick marks here. We talked about those earlier. That would indicate that B is the midpoint of AC, or segment AB is congruent to segment BC. Here I see the little single red arcs there. That indicates that ray BE is the bisector of angle DBC. So that means those two angles are congruent. I also have this little red box here in the corner. That indicates that angle ABD is a right angle. So when I see the little marks, then I can go ahead and make the assumptions. But just because it kind of looks like it, we can't make the conclusion without being told something in the description or without being given the markings in the picture that help us make that conclusion. So be careful as you're reading diagrams that you don't jump to unnecessary conclusions. Or if you're drawing models, don't draw special cases. If you're given the idea of a linear pair of angles, unless you're told they're both right angles, don't draw this for a linear pair. Because this picture can be misleading into thinking that, oh, these two angles are both right angles. The angles are congruent. True, that is a linear pair, but it's a special case. If they say draw a linear pair, just draw a linear pair. Don't draw right angles unless you're told to draw right angles. So be careful about jumping to conclusions. It's really been the death of more than one geometry student. Or maybe not their death, that might be overstating things a little, but leads to a lot of frustration and aggravation. So be careful. All right, we'll see you in class. All we have left now is the chapter test, and I will have a quick review for you on that podcast tomorrow.